So here are some notes on tropospheric pollution. So we're looking at tropospheric pollution. Now, just to emphasize one more time, pollution has to have a human adverse effect or some chemical that has a direct adverse effect either on the environment or on human health in order for it to be considered a pollutant and regulated by the EPA and other groups that are out there. All right, so we have two different kinds of pollutants. The first one we have is our primary pollutant. Remember, we also have point source and non-point source pollutants as well. But this is in air pollution we're going to be addressing today are primary pollutants. And primary pollutants are compounds that are considered to be pollutants that are directly into the environment. So they themselves are air pollutants. We have, first of all, our CO, so our carbon monoxide. Remember, carbon monoxide causes death because the carbon monoxide binds to the hemoglobin, and we essentially are oxygen deprived. So it can happen very, very quickly, usually in closed-in spaces when those levels build up and you no longer have oxygen. Another one is our SOXs, SOX. And the main one, primary one here is SO2. There's also SO4 as well. Another one is our NOxes, NOx. And the primary one here is NO2, our nitrogen dioxide. All right, that's a little bit different from our nitrous oxide, which is N2O. So this one is NO2. Now, both of these are considered to be respiratory irritants, and they can cause a lot of problems with bronchitis and asthma and can inflame those as well. Another one is our VOCs, VOC. And those are volatile organic compounds or hydrocarbons. You know them because their primary characteristic is that they are pungent. They're very strong smelling. So things like gasoline, lighter fluids, paints, glues, all those kinds of things can be VOCs. We'll talk about how those interact here in a little bit, but VOCs can also be irritations. So they can cause lung irritation, eye and throat irritation, and some people are more sensitive to them than others. We have particulate matter. We have two different ones. We have gross particulate matter or large particulate matter, and those usually are dealt with through the nose hairs and the cilia in the nasal passages or the lung passages, the bronchial passages. Where those can be pretty easily picked up, but they can still cause a lot of irritation to people. But the big one that they worry about is small particulate matter. What small particulate matter is anything below a certain micron level. These are particularly bad because what they can do is they can skip and get down into the lungs themselves, and they can destroy the alveoli. And the alveoli are the gas sacs where gas exchange happens inside the lungs. And so when those get destroyed, we have less lung capacity, which then affects our not only our respiratory system, but also our heart and cardiovascular system. And over time, they can also lead to cancer. All right, and then our other two are heavy metals. We have lead, Pb, and we have mercury, Hg. Now, lead was put into the gasolines to increase efficiency, and those were finally regulated out of gasoline in the 1980s. Mercury, it could still be found in the burning of coal. All right, so those are our primary pollutants. And these heavy metals, by the way, lead and mercury, also are neurotoxins. So they can cause problems with cognitive problems and other issues like that. All right, so when we have our primary pollutants, we also have up in the atmosphere some naturally found gases. So we have our nitrogen gas. Remember, that makes up 78% of our atmosphere. We have oxygen and also water vapor. So all of those things are present naturally in the atmosphere. Now, we also have these primary pollutants are going to can go through an oxidation reaction. What is required here is sunlight. So we have our sun coming up here. And then this oxidation reaction, we actually have the sunlight hitting on these chemicals, and they undergo a photochemical reaction. So photo meaning you have light present and chemicals. And what they're going to do is in these photochemical reactions, they're going to form our secondary pollutants. So our secondary pollutants are going to be over here. So these are not found, like they don't go into the atmosphere directly. They actually come up and then react. The primary pollutants react with either the naturally found chemicals such as nitrogen, oxygen, and water vapor to form these secondary pollutants. All right, so the big one here is ozone, O3. Ozone is one that forms in the daylight. So remember, it needs sunlight in order for the ozone to form. But it's very unstable, so it doesn't stay together for very long, and it will break apart and back into O2. But ozone is formed when you have your NOxes combined with your VOC, and it's going to form that secondary pollutant of ozone. Ozone, in addition to our small particulate matter, are going to form that brown smog that happens in cities where there's a lot of automobiles. Some other typical secondary pollutants are the things that cause our acids. So we have our SOxes and our NOxes are going to go to combine to create our acids. So the big one here is H2SO4. We also have HNO3 and H2NO3, I believe. That doesn't look quite right, but I think that's right. Another one is our hydrogen peroxide is also a secondary pollutant. And we have one called PANS. And PANS stands, oops, sorry about that. Let's go ahead and take that off. We have PANS. And I'm going to come down here and draw that out for you. So a PAN, because I didn't have this in the notes, is peroxycyl nitrates. I never say it right. I need someone to teach me how to do that. And what these are, you take your VOCs plus oxygen plus nitrogen or nitrous oxide, and they're going to form the PANS as secondary pollutants. All right, so that's how secondary pollutants form from primary pollutants. Now we're going to look at the sources for each one of these, and we're going to describe whether they are natural sources. We'll use an N to do that, or anthropogenic. And for that one, we will use an A as our designator. All right, one of the big sources of these pollutants, these primary pollutants, is volcanoes. So we have our volcano over here, and of course that is a natural phenomenon where these come out. Now they're going to release several different kinds of pollutants. The most significant one being our SOxes. So they're going to release that into the atmosphere. This is not a greenhouse gas. SOxes are actually the opposite, so they actually reflect light back out into, or radiation back into the atmosphere. So they're not going to hold heat in, they're going to release heat out. Another one is our COXes, and so this could be CO2 or CO. And then we also put out, they also put out particulate matter and small particulate matter. Okay, let's come down here and look at our little truck, since that's sort of the centerpiece of what we're doing. So we have our truck. Now, it is obviously anthropogenic, so we'll put our A there. Now, there's two parts to a truck. There's the front end and there is the back end right here, right? So there are chemicals that are released, or pollutants that are released on both ends of that. Now, it is a combustion engine, meaning we put gasoline into the gas pipe, and gasoline is what is burned. It's used with a spark, and then it releases then two things. It releases our COXes, CO2 and CO, and also our NOXes, NO2 primarily. Now, why do fossil fuels release these different things? Not just carbon, but they also release sulfur and they release nitrogen. And the reason is because all living things contain those chemicals. So when they're burned, they're actually releasing not just carbon dioxide, but they're releasing these pollutants as well. Coming out the backside, we have several things. One, we have our COXes. So carbon monoxide is a big one that comes in because we have incomplete combustion that happens inside the engine, and then that gas is poured out of the tailpipe. So it's essentially they're connected to each other just like that. Another thing we have coming out is the gasoline doesn't get completely burned off, so it gets released in the form of VOCs. NOXes are released, and small particulates are released. Now, when you get your car inspected, most of the time they're looking for ways in which you cut emissions down. So an older vehicle is going to release more of these than a newer vehicle. Also, those guys that ride around in Flower Mound that will spew out those smokes, that car does not pass inspection, that pickup doesn't, and they're putting out a lot of small particulate matter. And if you think about how dangerous those are, it's more than what we do. Now, unfortunately, our small particulate matter is not being, it's kind of being put up as something that no longer needs to be regulated. A lot of people don't think there is a direct tie-in to adverse physical health through small particulates, but if you think about just smoking in general and all kinds of ways in which small particulates cause damage to the lungs, it's a real fight. All right, the pickup's driving along the road and it's probably kicking up a lot of dust and other particulates, so we'd have our particulate matter that's coming up off of that. Our road is also, maybe it's made of asphalt, and asphalt combines tar and rocks essentially held together, and when they get hot, it's going to release a very pungent odor, and those are some VOCs that are going to come up off the road like that. All right, you'll notice there's a little place back here. This is going to represent our coal burning power plant. Okay, so coal in particular gives off a lot of different kinds of compounds. Most notably, of course, is our CO2 or COXes. It also gives off a lot of sulfur, and this one is one that's being regulated more and more as time goes by, but it gives off a lot of SOXes. Also, small particulate matter comes out, and it also is responsible for the release of mercury. Now, mercury and SOXes have both been regulated quite a bit so that they're captured when there is coal-burning power plants, more so than they used to be. And that's because people don't like acid rain. I don't like mercury. And remember, mercury is a bioaccumulator, so that's also problematic. And this, of course, is anthropogenic in its effects. Okay, off to let's do a couple others over here. So we're off in kind of in the mountains. So what we're going to do is we're going to draw some trees over here, some pine trees. So I'll put some pine trees growing off in the background. We'll put little stems on them down there too. And remember, conifers release a very pungent smell, and what they are putting out is VOCs. And those VOCs actually are what give the Smoky Mountains their kind of haziness, or they're basically their ozone pollution, and it happens in the summertime. And this, of course, is a natural source of VOCs. There's lots of natural sources of VOCs, as we can find out. All right, let's put down here. Let's put a little campfire. So we have a campfire going out here. And in a campfire, we usually burn wood, right? So we have a little stacks of wood going here. And we can put fire coming out of it. Just like that. So those things, oops, it didn't switch to the orange. So we have fire going. All right, and so let's say we also have a person. Maybe it's a girl. She's sitting there at the campfire with her little friends, and they're roasting marshmallows, or let's put a marshmallow in there. So she got a little marshmallow there, right? She's about to catch it fire. Let's put her some hair on there. Let's see, what color hair do we want her to have? With some brown hair coming way down her back. All right, so she's burning something, right? She is burning biomass. Now, we talked a lot about the burning of fossil fuels, but we haven't talked about biomass. And when we get to our unit on energy, this one's going to be a pretty strong distinction that we're going to make. Now, with burning biomass, you're burning a lot more than just carbon. With gasoline, it's gone through a refining process, so they've removed all of the sulfur out of that. Natural gas itself is basically just methane gas, but when we burn biomass, we're burning everything that was inside that living plant, right? And so in the process of doing that, what we're releasing then are lots of different things. So it can give off COXes, and it will undergo some incomplete combustion. Now, at a campfire, you're going to have enough oxygen there, or enough of air movement that the carbon monoxide isn't going to affect you very much. It's also giving off SOXes and NOXes. Also small particulate matters coming out of it, and maybe even some VOCs. All right, so it's going to release almost all of it. Now, let's say that the wildfire got out of control. The fire got out of control and started burning out this way as well. All right, so we have fire out of control, things burning. Question: is this natural or is this anthropogenic? The answer is it depends on how you look at it. So it can be a natural source because we are burning wood, right? Or if it's a wildfire that's caused by just natural means, lightning strikes or those kinds of things, then it is natural. But it can also be anthropogenic. So if we start the fire intentionally, or it's just our plan to burn things, then it becomes anthropogenic. Or slash and burn, like we have with a lot of things going on in the rainforest. Okay, so those are basically our pollutants. I want to address real quick just a little bit more, not necessarily about pollution. All right, so I want to just kind of put a break on this, and we're going to make a distinction then between pollution and greenhouse gases. Okay, so off to the side we have our greenhouse gases. And we're going to talk a lot about these with climate change, but I just wanted to make sure that we have kind of a list over here of these different kinds of gases. Some of them are pollutants and some of them are not pollutants. For example, our methane gas is not considered to be an air pollutant. Our CO2, not really an air pollutant. Now, we can make a case for it. We can say that it's going to have adverse effects because these things are trapping gases, right? They are trapping heat that's going to lead to climate change, and then we'll go off on the weeds, but they're not regulated as pollutants because they're not seen exactly that way. Our nitrous oxide is actually a pollutant. So nitrous oxide can affect your cognitive abilities. So it's sort of a neurotoxin. So, it's known as laughing gas. But so it's pretty regulated, but you can still purchase it. But it is a greenhouse gas. Another natural one that's found is H2O. In fact, that's probably the most efficient of the greenhouse gases that we have. It has the most greenhouse potential to it, but it doesn't last for very long. Ozone is also a greenhouse gas when it's tropospheric. Let's just set that out there right as it is. All right, those are naturally found compounds. We also have some human-made ones, and these are our fluorinated gases. Now, fluorinated gases are man-made. We have two classifications. We have our CFCs, and so as you look at ozone depletion, CFCs is a big one there. They deplete ozone, just as they say. Now, they were replaced by another set of gases known as HFCs. Now, HFCs they do not cause ozone depletion at all. That's why they were replacement gases for the CFCs. However, they are big old fat greenhouse gases, and they can last for thousands of years, some of them tens of thousands of years. And so these are now being replaced by lesser effective hydrofluoric or hydrogen fluorinated gases. And those are they're only lasting like tens of years. So not quite as bad as the ones before. And we'll talk about some of the sources for each one of these greenhouse gases later. But remember, they are not pollutants necessarily. In fact, the only one that's considered to be a pollutant is that one right there. Okay, that's it.